I hate paperwork. I'm terrible at it, and it's not something I enjoy. However, if you want to be a good technician, you're going to have to deal with paperwork. So the CompTIA A+ mentions some of the types of different paperwork, the documentation you need to know, as I like to call it, that you're going to be seeing on the exam. This documentation is all over the place, so I'm just putting it all in one big pile for you. You guys ready? One thing that's going to be really important are network topology diagrams. At least that's what CompTIA calls it. To me, what we're talking about is how do you document all of your computers and printers and switches and routers and stuff like that. Now, there's a lot of different ways to document this. In fact, there are companies out there, like a company called SolarWinds, whose only job, well, they do more than this, but inventory management is a big part of their job. So one of the things they'll do is you run this piece of software and it'll go out and find all the computers. Now, there's a big question about how do you organize this? Now, to me, there's two different types of diagrams that you're going to run out there and see. Number one are going to be what I'm going to call logical diagrams. A logical diagram organizes stuff like, well, take a look at this example right here. So you see I've got these big circles that are showing all my different network IDs, and I'm showing different computers within each one of these little networks. Notice I've got diagrams for routers, and I've got everybody's IP address documented, that type of thing. We can also do physical diagrams. A physical diagram is how everything looks, and it usually manifests as a floor plan. So if you take a look at this floor plan right here, you'll see that I've got all of my different cable runs, where the cable runs are running to. Here's my distribution frame in the corner, and it gives me a real-world idea of how this is all organized. So both of these could arguably be called topologies. A logical topology is how things are organized electronically, in that case by IP address, whereas a physical topology has to do with how things are physical in the real world organized. These are really handy things, especially if you're trying to go to a particular office and you want to know what's in there. Referring to this type of information is very handy. Now, where do I get my information? People are always like, Mike Myers, how do you know how to fix so many different things? And the answer is, I don't. I know how to fix very, very few things. My real skill is I know where to find information. Yeah, I know in today's world we can all go into Google and type in a thing and you'll get some answers, and there's nothing wrong with that. But one of the main places I turn to are repositories of knowledge that are organized by the people who are most interested in it. For example, if you've got a problem with Windows, there's a pretty good chance you're going to end over at Microsoft.com. Now, Microsoft.com many, many years ago came up with a concept called knowledge base. And a knowledge base is just how they organize all the things they've learned about their operating system and Office and all their different tools, and it's now a vast database which is easily searchable online on the Microsoft website. Now, CompTIA wants to use this term for everybody's pile of data. Don't do that in the real world. The only real knowledge base is Microsoft's. However, there are lots of people who have big knowledge databases. Here's a great example. Good old Amazon Web Services has wonderful documentation for all kinds of issues that you might run into. Another great one is Cisco. Heading over to Cisco.com can give you answers on everything from an old router to a new switch and detailed information that you absolutely can't believe. Easily searchable, great information. So for me, these are the type of places I go to. I usually don't do a Google search if I know the kind of department I'm talking about. I'm going to go to one of these sites and search within them to get the information I need. Now, the other big thing that people worry about is regulations and compliance. So we're always worried about, are there things out there that we're supposed to be adhering to? Who regulates us as an entity? Who are we supposed to follow in terms of rule set? Well, there's no simple answer to that. It really depends on your industry and what you do. But things like, for example, laws are very important. There are certain laws that really affect people that really are a big deal when it comes to how you deal with your IT department. We also have things like standards. Certain standards define how you're going to be doing things. These can be very important. We also have what are known as best practices. Most organizations who are handing out software or hardware have a way that they want you to configure things or set things up or troubleshoot or look at stuff, which are known generically as best practices. Microsoft best practices is a term we use quite a bit. And these are great places to look for when we need to figure out how we're going to do things. Also, stuff like tradition comes into play. Now, I'm not talking Fiddler on the Roof here, but I am talking about stuff that has to do with how your organization has tended to deal with one issue or another, and those traditions can be very important. And of course, the last one is common sense. So many times we run into issues as IT departments where we forget that incredibly simple and important thing. I had probably the person I learned more about IT from was a gal named Sue Lennox. Sue, I hope you're still out there. And Sue was a good old Louisiana gal. And I'd be the tech who'd be sitting there going, all right, so we got to reconfigure this and twirl on that and press on that. And she'd be the one who goes, Mike, is it plugged in? And I always loved that, and I've never lost that from Sue and her ability to make me drill down and just use common sense on problems. Now, when you put all of this different stuff together, you generate policies. Now, we discussed policies in other episodes, but there are two policies in particular that tend to hit people at the A+ level. The first one is an acceptable use policy. Anybody who's ever started as a new employee at any kind of enterprise probably signed this and didn't even think about it. An acceptable use policy simply defines what you can and cannot do with company equipment. So there are certain websites you're not supposed to go to. They're not happy about you running an eBay store from your office. They don't want you taking home desktop systems over your Christmas vacation so that you can play games and things like that. So acceptable use policy defines what you're allowed to do and not to do with the equipment of the enterprise. Another policy is password policy. A password policy basically says, look, we know that there's passwords in all kinds of aspects of our enterprise. So in general, here are certain things we expect. A minimum length, a type of complexity. How often do we change the passwords? Who are the people who are in charge of this? What type of storage for passwords do we use? All these types of things. And as an employee, a lot of times you find yourself signing a piece of paper that says, I will always make complex passwords. We don't even think about it a lot. In fact, it's often buried into an acceptable use policy, but it is a policy all the same. Be aware that CompTIA only talks about these two policies. Folks, there are thousands of policies within an individual organization. These are the two that we as A+ level techs tend to run into. Last thing I want to talk about, and this is something we really do run into a lot, and this is inventory management. Every time we come in with 8 new servers or 150 new laptops or whatever it is, it's invariably our job to do the front end work of inventory management. And that usually means that we're stuck having to stick something on the laptops or the servers or something to let us know that not only is this our equipment, but there's an identifying number or something like that. Here's one example right here. If you take a look, these are examples of what we call asset tags. And if you take a look at these asset tags, you'll see they all have numbers. A lot of them have barcodes, and they are an incredibly wonderful and convenient way for us to track inventories of all the different type of hardware. You go into any large enterprise, you're going to be seeing asset tags all over everything. There was a very large company I was at not very long ago that had asset tags on every one of their coffee pots. I kid you not. Data is everywhere in a network, and you being an A+ certified technician working on computers, you're going to be really, really close to that data. If you're in an enterprise, their data is precious. Data could be payroll information. Data could be inventory. Data could be proprietary manufacturing processes. Data can be very, very important, and it's your job to guard that data. However, there are 4 types of data that are so important that if you don't guard them properly, there is a chance that you could have civil or even criminal penalties. So in this quick little episode, I want to make sure that you know what these 4 types of data are. So let's start with the number 1, and that is personally identifiable information, or PII. In today's world, it is very important that you protect personally identifiable information. For example, if you know my social security number, you have a legal obligation to protect that with the way that you handle data. If you have my phone number, if you have my address, if you have all kinds of information that is personally identifiable to me, Mike Myers, you have an obligation to be careful with that. Another example which is close to this is personal health information, or PHI. So if you want to know my blood type, or if you want to know what my doctor's been treating for me for the last couple of years, if you want to know what vaccines I've had, all of this is known as personal health information, and there are very strict laws protecting me from that information getting out into the wrong hands. Now, those are laws. Well, there is one more law, and this is more European. What we have is the EU General Data Protection Regulation. What the EU makes is a rule that says you as a person have the right to control the information that people gather from you. This is mainly for the web. You've probably seen stuff, well, for example, take a look at this. So here I am on a website, and you'll see that it allows me to control what type of cookie information I'm going to allow people to look at. So these can be very, very important. So PII has law support. PHI has law support. GDPR has law support, but that's not the only place where regulated data comes into play. Another great example is the PCI, the Payment Card Industry DSS Data Security Standard. These are all the different banks that issue credit cards. And if you want to be a person who takes credit cards, you have a responsibility towards that data. Now, you need to be careful here because you as an individual little mom and pop company, you don't have a lot of responsibility. But that data responsibility really comes into play. For example, the people who make credit card swipers. How is that data stored when they take the credit card? Or large organizations that provide merchandising services for websites. How do they control that data? So your job as an A+ technician is you're not going to be a security expert on regulated data. That's not your job. What does get us in trouble is because we are unfamiliar with these things, we can often do simple little embarrassing things, putting something on a thumb drive or allowing wrong permissions on a particular file to get us in trouble. When you think about data, consider the fact that there are civil and legal repercussions to the way you deal with it. When in doubt, talk to your supervisors and sometimes get it in writing because it might save you. If you hang out with me long enough, there's one thing you're always going to notice is I've got to have the newest and greatest of everything. A new Google phone comes out, I've got it. Some new type of IoT stuff comes out, I've got it. A new video card goes out, I got it. Windows is upgraded to the latest version, I've got it. I've always got to have the newest and coolest stuff. Well, that's great for Mike Myers as a person and my choice to mess with the cutting edge of technology. But when you're in an enterprise, to make changes to an existing business practice, if you're wrong, it can be absolutely disastrous. So any good organization is going to create the concept called change management. So change management is the organized, smart, carefully set up system which allows changes to take place within enterprises and keeps them from losing money or equipment or people or whatever it might be. The A+ has a very light touch on change management, and probably what they're trying to find here is that you as a tech, if you want to put new monitors in the accounting department or something, they want you to have some sense of how this works. So it's a light touch, but let's go through this. First of all, the big thing in any organization is there's going to be a change board. This change board is going to meet every month, every every quarter, whatever it might be. And these are people whose job is to look at requests for changes and then to approve or disapprove them. So in general, if you want to make a change, there are forms that you're going to have to fill out at your organization with certain information they're going to expect. Number one, they're going to look for documented business practices. So if you want to put new monitors on a graphics group, you have to document the business practices and how this change is going to help improve that business practice. And if you can put dollars behind it, that's even better. So the purpose of the change is almost always going to be to improve productivity, but not always. You can have situations where, example, people can actually create better output or something like that simply by improving the type of equipment or software or whatever it might be. The other thing you need to talk about is the scope of the change. Is this change going to just affect the accounting department, or is this going to affect the Dallas office, or is this going to affect the European offices as well? So you need to get an idea, and again, putting dollar values is a very, very good idea. The next thing is a risk analysis. Basically, what are the downsides to us making this change? What are some of the risks involved with that? Risk could be, how long does it take to make the change? Is there training involved to make the change? Is there a possibility of incompatibility? A lot of these things have to be looked at, and trust me, if you don't bring it up, the change board's going to bring it up for you. Now, assuming the change board gives you a tentative approval, the big thing you're going to have to do is you have to plan for the change. How's the equipment going to be brought in? Whose loading dock is going to be picking it up? Who are the people who are going to be assigned to install it? Are they going to be doing this over the weekend so that the accounting department isn't down? Are they going to do it overnight? How are you going to handle training in the accounting department? Do you want to prepare ahead of time and have some classes? All of these things come into play, and you plan for the change. Now, all along the process here, you're always getting end user acceptance. Don't go thinking that you're going to make everybody in the accounting department happy by bringing in new monitors without giving them some kind of warning. So end user acceptance certainly ends when everything's installed and they're happy, but it actually starts at the beginning of the change process, where you as a tech are going, man, you guys, if you saw these new monitors and these 4K, they're going to make your spreadsheets pop. You guys, get those end users with a buy-in to what your change is so that they understand it, make sure that their management is on board, and that way, by the time the change takes place, everybody's happy. Now, the downside to change management is that your great idea about the 4K monitors for the accounting department, well, it didn't work. You made a mistake. It happens all the time in our industry. So what you then have to have is what's called a backout plan. Okay, it didn't work, we've made a mistake, how can we get everybody in the accounting department back to where they were before? And that's where the backout plan comes into play. Do we keep the old monitors in a warehouse for 90 days? How do we go ahead and prepare for that? Who are going to be the people to replace it? What costs are going to be absorbed by what department? All of these things come into play for a backout plan. And generally, as is known for almost any process that you're going to see on any CompTIA exam, the last step is always going to be the same. Document the changes. No matter what takes place, always go through the process after the changes have taken place, go through and document exactly what has happened. Also, a really good one to add when we talk about documenting changes is the concept called lessons learned. Lessons learned is a great way when you're documenting the end result of something to be able to say, what was our real takeaway from this particular change? Documentation, it's key. One place you really need to be organized in your thoughts and in your zen is in the world of backup. You need to take time and think about what you want to back up, how you want to back up, and what procedures you're going to use for that backup, because if you don't think about this beforehand, when you lose something, you're in big trouble. So what I want to do in this episode is we're just going to talk about the zen of backup and some of the things that we need to organize ourselves. Now, if you take any more CompTIA courses from me, like Network Plus or Security Plus, one of the words that comes into play is disaster recovery. Now, disaster recovery is a big topic that talks about, you know, what if we lose our servers and things like that, but that's not where the A Plus is going. What the A Plus is going towards is what you need to do to avert the disaster if your phone dies, or if your laptop goes, or your desktop system. It's very individual system based. So with that attitude in mind, let's talk about the idea of backup and then also recovery, because backup is only half of the process, right? Recovery is that you actually take that backup and run it. So what are you going to back up? Well, it really depends on your platform. First of all, with smart devices, and we have episodes that cover this already, you're going to be using some kind of built-in backup tool, which is going to be cloud-based from scratch, and it's going to be doing an absolutely fabulous job for you. This is pretty much automated in the Apple world, but if you're an Android person, you probably have to turn it on to actually get it to work, and whatever cloud service is associated with your operating system on your phone, it'll back it up to. Those work great. Where things get challenging is on systems that are running like Mac OS or Windows, because particularly with Windows, there's been such an evolution in the zen of backup that it's almost hard to keep track of. Like, for example, for years, our backup methodology was on these things called tapes, and you actually stored onto a digital tape. And the backup was done on a file basis. So like the idea of backing up your operating system in the old days, we never would do that. Or backing up an application, why would anybody do that? If your system goes down, you get a new system, you reinstall Windows, you reinstall Office, and you reinstall Adobe Creative Cloud or whatever you're using at your company, and then the data, which you have backed up, is then brought back onto the system. So file-based backup was the way we went for a very, very long time. You can still do file-based backup on any Windows or Mac OS system. I'm going to do it here on my Windows system. Come take a look at this. So I'm going to open up Control Panel, and you'll see an option that says Backup and Restore Windows 7. So what I'm going to do is I'm going to set up a backup. I'm going to do a little network backup. I'm on a network, so I'm going to back it up to a big file server. So it wants me to put it over here on a D drive, but I don't want to do that. I'm going to save it to a network, and I just happen to know got a nice little network location here. Whoops. And in this case, I'm going to back it up on my network. Now here's the part that I'm more interested in showing you. So it's going to say, let Windows choose or let me choose. So I'm going to say, let me choose. And what I'm going to do here is I'm backing up files with this. These types of old school backups are file level backups. If you're going to be backing up system images, that's going to be an image level backup. Remember, an image is going to back up an entire drive, an entire partition from stem to stern. It's going to back up the operating system, it's going to back up all the installed applications, it's going to back up all your installed data. It's just the entire thing gets basically copied. Now this could be copied, for example, to an external drive. I could copy to a network. I could even copy to the cloud in some situations. So in this particular situation, I'm going to be doing a file level backup, and it's going to be copied to a network location. So if you take a look, right now by default it says backup data for newly created users. I don't want to do that. And here it says Mike's libraries. And also now it wants to do a complete file level backup of my entire C drive or D drive. I'm not saying I don't want to do that, but normally I would be doing a image level backup for that. So what I'm just trying to do is get my critical files. So here's all my different libraries in Windows, and it has additional locations. So if I want to copy my desktop, my downloads folder, all kinds of stuff, I can choose it right here. This type of backup is, in my opinion, old-fashioned today. especially with things like thumb drives. My personal information, I'm going to back it up right here. You want to see the ultimate backup? Put a thumb drive in your computer and back up the files that are important to you. So this is really the way to go. However, you do have some other options, but let's go ahead and finish this up. Now it also wants to do a system image. I don't want to do that. That's a whole other type of backup, and we have other episodes that cover that. So I can set this up and I can run a backup. I can schedule it, anything I want to do. We'll let that backup go. The main reason that file level backups are, in my opinion, sort of old-fashioned is, number one, we now have storage systems, like even this right here is a 3 terabyte drive. So I can store 3 terabytes in here. My SSD on this guy is only 2 terabytes. I can put my complete image on this thing. That's convenient. The other problem I have with file level backup is, notice I'm just backing up personal files. So if I had a problem with this system, I'm still going to have to reinstall Windows. I'm still going to have to reinstall my applications. Then I can run the backup and bring back all my personal files. So image level backup is really, really popular right now, but do be aware that you can still do it the old-fashioned way if you want to. The other thing to keep in mind is that if you're going to be doing file level backups, there might be situations where you want to back up critical applications. If that's going to take place, you really can't count on the file level to get it, because, well, where do you go? You go into program files and pick those particular critical applications? No, usually what you're going to be reduced to is going yet again to a system image level to go ahead and make that backup. Yeah, Mike's pretty excited about image levels these days. Okay, the other big thing you need to be aware of while you're doing this is that you really need to test your backups. Failing to test a backup can be a big problem. You're backing up to a little hard drive like this and it sits there for 2 years. Is it still working? You might want to give it a test every now and then. The one place I don't worry about testing is if I do a cloud level backup. So let's talk about cloud. Again, with these devices, it's cloud by default, so that's really easy. But you can do backup onto the cloud for these types of systems. At this point in the game, it's still kind of new, but this is moving very quickly, and it's probably going to become more and more common. So here in Windows, I can actually go over to my OneDrive, and let's go over to Settings. And here under Autosave, you'll see it says Protect Your Important Folders. So I'm going to go ahead and hit Update. And by default, it wants to back up my desktop, all my pictures, and my documents. You don't have a lot of control here. So just for funsies, I'm going to uncheck that. And I just start the protection. It's pretty easy. What's happening is that all of my pictures and all of my documents are now being sent up to my Microsoft OneDrive account automatically. It's convenient, but on the same token, it can absolutely eat up bandwidth. So you've got to be really, really careful with some of these tools. Okay, so it looks like everything's getting synced really nicely, and all my documents and all my pictures are being backed up. The only other thing that I worry about backing up are accounts. Now, when we talk about accounts, this can be a big deal. For example, I've got a Gmail account that's connected to this particular phone. If I lose this account, your recovery options are pretty small. You've got to be really careful with these guys, especially if you're using a multi-factor authentication. Like I made the mistake once of setting up my Gmail so that every time I did something on my phone, it would then send me a text when I'd have to type in the text value, and then I lost my phone and I was in big trouble. Now, if you read the documentation that comes with this, Google does a great job. They provide a secondary phone number you can use. They provide backup codes, physical codes. You can print it out on a piece of paper. If you're going to be doing stuff like that, you need to be aware. If you totally lose your ability to get to this, nobody at Google is going to help you, and you're out of an account, and that can be disastrous sometimes. This is also true for any online account. Things like Amazon or banking accounts and stuff like that, especially the ones that use multi-factor authentication. Be sure to use backup codes if they're available. Be sure to use a backup phone number if they are available. Make sure you have a way out, especially with things where your money's involved. I'm usually on the phone talking to the bank going, okay, so if this scenario takes place, what would I do? And make sure that you have options, and make sure you know the name of your earliest childhood friend and your mother's maiden name, because that kind of stuff comes into play. So keep this attitude in mind when you're thinking about backup. Backups are absolutely critical. We've never lived in a world where they are easier to back up both our mobile devices as well as our more traditional systems. But if you don't do it, you're going to be in trouble, because there's only two types of people in this world: those who back up and those who haven't lost any data yet. My old Dell laptop. Me and this guy have seen a lot of plane trips together. We've been to multiple continents together, but unfortunately, he's kind of ancient and I've got a better laptop and I need to get rid of this. So what I want to talk about in this episode is recycling, because the one thing you're not going to do with this laptop is throw it in the trash. There's good reasons for that, and that's beyond simply being a good denizen of this earth. And that is, there's data on these, there's stuff like that that really comes into play. So when we're talking about getting rid of old computer equipment, the word is recycling. So let's talk about some of the different types of parts we have laying around. The big one that everybody asks me about are batteries. So my rule is little alkaline batteries like these AA's, you can throw them in the trash, just regular trash. However, things like lithium ions and other types of batteries like this, these have very specific recycling methods, and you want to recycle these guys. And just go to the right recycler. In fact, they have recyclers for all kinds of stuff. Toner cartridges for laser printers. There are people who will take them and recycle them. And when I say recycle, they will refill the toner cartridges and get them back out there. Old CRT monitors. There are people, they won't pay you for them, but they will actually go through these CRTs and get metal out of them and things like that. Cell phones and tablets, there's plenty of people who will buy these things straight out. The only thing you want to remember with these is make sure that you delete your accounts and then do a factory reset before you give them to anybody, because you don't want them to have your banking information and things like that. So make sure that that's all wiped away. The big thing we worry about is desktops and laptops. In order to get rid of these guys, there are certain things you need to consider. Number one, you've got data on these things. So if you're going to be recycling these, there's lots of people who take them. You know, here in Texas, there are organizations who will take any computer, an old server, an old desktop, an old laptop. They love those things. But the one thing they don't want are your hard drives. So when it comes to old hard drives, there's some certain rules that come into play. You've got to get rid of these. Now, one thing people will always tell you about is they'll go, why don't you low-level format it? It cracks me up when I hear that term. Low-level formatting was something that we did with very ancient drives that had names like ST506. These are over 20 years old. And there was a process that you could go through called a low-level format. Today's modern drives are all basically ATA drives. Now keep in mind, what I'm talking about are rotational media drives, not SSDs. And these are low-level formatted, but they're low-level formatted at the factory. And basically, that's where we set up all the different little sectors. So they're pre-assigned in there, and that's a low-level format. You cannot low-level format these. It doesn't happen. So if anybody tells you, including the A+ exam, well, they're just wrong. So you can't low-level format. What you can do is a regular format. In fact, that could often be a great way to wipe data off of a drive. But if you do a regular format, keep in mind that that doesn't necessarily mean that all the data is actually erased. You've taken out all the cataloging and indexing, so it's very, very difficult to get to that data, but it may not actually wipe the data. So when we're talking about wiping data or overwrite, to me that's the exact same term. What we're talking about is writing data over and over again onto the drive, getting rid of what was ever there before. So you'll hear terms like zero wipe, where they write just nothing but zeros. Then you'll see things that there are military standard wiping rules, where they'll wipe all zeros, and then they'll wipe 01010101, then they'll wipe 1111, then they'll wipe random, and they'll keep wiping it, usually 7 times. In theory, if a part of a drive has been erased or written on less than 7 times, that data could still be recovered. I don't believe that personally, but it's a term you hear out there. So there are great tools out there that are just designed to overwrite your drive over and over again and make sure that the data is gone. But just because the data is gone, especially when you start getting to government agencies and such, that's not good enough. Sure, take the rest of the laptop or old desktop and donate it to whoever you want or a recycling center, but just because you've wiped a drive, that's not enough. You usually need to consider some form of substantial, permanent destruction so it can never be used again. One way you can do it is called degaussing. So here's a picture of a degaussing machine. So basically what this machine does is you drop a hard drive in there and a massive magnetic field goes through the drive and renders it completely unusable. It can't be used. It's gone. It's just junk. Other organizations will do things like, for example, they'll shred it. So they can put it into a shredding machine. There are even little punch down machines where you put it in the hard drive, close the glass thing, press a button, and this big press comes in and crushes it. There are incinerators, although incineration is usually not a very good idea for drives. We'll often see it for like old floppy disks and old tapes, things that might be laying around. Those burn pretty well. In fact, there is a lot of organizations that not only will they take all of your old drives and destroy them for you, they'll actually come to you with their destroying machine, a degausser or a press or whatever it might be, and they will destroy all your mass storage right there on your premise and even hand you a certificate of destruction verifying the work that they've done and that these devices are no longer readable in any form. But to me, if you're really paranoid, you don't have to go buy a $25,000 degausser or a $10,000 press. If you're me, just take an old drill, put about 3 holes in it, and nobody's ever going to read that data.